Hello and welcome. Today we are pulling back the curtain on some of Python's most powerful and, let's be honest, kind of magical features. We're going to unlock what allows standard Python objects to do some truly extraordinary things. So let's get right into it.
Just imagine for a second, what if you could give your own Python objects actual superpowers? I'm talking about the ability to behave in ways that you thought were just for Python's built-in types. You know, like dictionaries and lists.
For example, picture a configuration object. Instead of some clunky lookup function, you could just access its settings with simple, clean dot notation, something like config.database.host. Super intuitive, right? And so much easier to read.
But what if that exact same object also let you get that data using dictionary-style square brackets? I mean, how flexible is that? It's perfect for when you're working with keys that might be changing.
So that's our central puzzle for today. How on earth can one single object support both of these ways of getting data? How can it act like a regular object and a dictionary at the very same time? Well, the answer is buried deep in Python's core design. The secret, it turns out, is a set of special methods that acts like a kind of hidden rulebook for our objects. You'll hear them called Dunder methods, which is just short for double underscore. These are the absolute key to customizing the fundamental behavior of any object you create. You've definitely seen at least one of these before, init, the constructor, right? But guess what? There are dozens more. These methods are basically Python's way of letting you hook into its built-in operations. When you use an operator or a function on your object, Python looks for a matching Dunder method to run. It's that direct.
Okay, so let's unlock our first superpower, taking complete control over how attributes are accessed on our objects. This is how we're going to solve that first part of our puzzle, the whole dot notation thing.
The real key here is a method called _getAttrib. Now think of this as a fallback. Python only, and I mean only, calls this method after it has searched everywhere else for an attribute and comes up empty. This makes it the perfect safety net for dynamically creating or calculating an attribute right when you need it.
But you have to be really careful not to confuse it with its more powerful and way riskier cousin, getAttribute. See, this method is a total gatekeeper. It intercepts every single attribute access, no exceptions. If you try to access any attribute inside it, well, it just calls itself again. And boom, you've got an instant infinite loop. So for pretty much all cases, the safer fallback, getAttribute, is what you actually want.
Now, control isn't just about getting attributes, it's also about setting them. With _setAttribute, you can jump in and intercept any assignment. Think about it. You could validate an email address the moment it's set on a user object, or log any changes to a sensitive setting. But here's the pro tip. Inside this method, you can't just write self.name equals value. That would call _setAttribute again, and you're back in that infinite loop. Instead, you have to call the base object's _setAttribute to safely store the value. All right, so that solves the mystery of the dot notation. But what about the dictionary-style access with the square brackets? For that, we need to unlock our second superpower, making our objects behave just like native Python collections.
This is all made possible by something called the container protocol. Now, this isn't a formal thing you import or anything. It's simply a convention. It's like a gentleman's agreement. If your object implements a specific set of Dunder methods, Python will automatically know how to treat it like a container.
And it all starts with getGetter. When you write something like config for database, Python, behind the scenes, translates that into a call to config.getGetter database. And that right there brilliantly shows the direct link between the syntax you write and the Dunder methods that power it.
And this same idea applies to other common operations. You want the built-in len function to work on your object? No problem. Just implement the _len_ method and have it return the size. It's really that simple.
And for the in operator, which is so crucial for checking if a key exists, all you need to do is implement _contains_. And by putting in just these few methods, our config object can now perfectly mimic a dictionary. And just like that, the second half of our puzzle is solved. So we've given our object attribute control, and we've given it collection-like behaviors. But there is one more superpower that is incredibly useful and frankly a little surprising, making your object callable, just like a function. Yeah, you heard that right. By implementing the _call_ method, you can literally put parentheses after an instance of your object and execute code. All of a sudden, your object isn't just a container for data anymore, it's an action just waiting to happen. So why on earth would you do this? Well, it's perfect for creating objects that act like functions, but also need to remember information to maintain state from one call to the next. Imagine a simple counter object. Every time you call it, it just increments and returns the new value, because it remembers the previous count. It's like a function with a memory.
You see, by understanding these Dunder methods, you're not just using Python anymore. You're actually tapping into its very architecture. You are becoming the coder magician, bending the language to your will to create more expressive, more intuitive, and just plain more powerful code.
So let's just do a quick recap of the 3 superpowers we've unlocked today. First, we grabbed fine-grained control over our attributes. Second, we made our objects behave like all the familiar collections we use every day. And third, we even made them callable, just like functions.
What feels like magic at first is really just a reflection of Python's incredibly thoughtful and consistent design. These aren't hidden tricks or hacks. They are powerful tools built into the language's core, just waiting for you to use them. And now, you have the keys.
So, I'll just leave you with this one question. Now that you understand the secret rulebook of Python objects, what's that seemingly impossible, elegant, or powerful object that you're going to build first? Thanks for tuning in.